Welcome everyone. Our problem today is what will happen if we create a vacuum inside of a can and place it upside down in a pan of water. You can see here for our experiment, we have one alcohol lamp, a graduated cylinder that will have 30 milliliters of water, a pan filled with water, beaker tongs, a ring stand, empty can of Coca-Cola, wire mesh, and one ring. And also one lighter. I've already lit the alcohol lamp. What we're going to do is we're going to pour 30 milliliters of water into this can. And we're going to heat the water up until it has a boil. We're going to place this alcohol lamp right in underneath it, and we're going to heat it up. It generally takes about 2 to 3 minutes. So the purpose of this is to show you the power and the pressure of our atmospheric air. Also, what happens when we create a vacuum on the inside of this can. And then we're going to flip it upside down, much like you see here. We're going to take this, put it into the pan filled with cold water, and we're going to see what happens. Water expands by anywhere between 1,600 to 1,700 times greater volume when it goes from a liquid to a gas. And the results are often quite amazing, and sometimes even if you're working in some industrial facilities, it can be very, very dangerous. So it does take some time. What we're going to do, what I want you to do now is I want you to make a form of hypothesis. We already have our problem. So you're going to follow our basic steps of a scientific method. There's definitely more steps involved in this, but these are just the basic steps. Problem, hypothesis, experiment, observation, conclusion. And you're going to use our PHEOC method, P-H-E-O-C. P equals problem, H equals hypothesis, E, experiment, O, observations, C, conclusions. Now with this one, I have a larger ring. It takes a little bit more time with the wire mesh. I have an insulator on there. So it takes more time. This is a good time for you to go ahead and be making your hypothesis about what you think is going to be happening. Please be using it if then because. If this happens, then this will happen because of these reasons. So keep in mind that water, when it goes from a liquid and goes into a gas, takes up more volume. Imagine, if you will, that if you have just one of me and I'm in one quantity of water, well, and I'm in the state of a liquid, and I change state, I boil, I become steam, a vapor, a water vapor, there would all of a sudden be 1,700 of me in this room. So it takes up a lot of space, also more energetic. It's taking more energy. Those molecules are moving really fast. Those H2O molecules are moving very, very fast. And then what happens when we cool it down and prevent air from rushing in? So your prediction, your hypothesis for a problem here, what will happen if we create a vacuum inside of a can and place it upside down in a pan of water? What's going to happen? So right now, inside of this can, those atoms, or those molecules are moving really fast, and they're starting to take up more space. And then what happens is we're going to cool it down. So if it took up more space at first, and then we cool it down and into a liquid form, it's going to take up less space, leaving a vacuum. I'm trying very hard to be able to help you out with your hypothesis. Also, what you're going to have is in your experiment, and I also have safety goggles on. You have to have all your different materials. Safety goggles, beaker tongs, graduated cylinder, a lighter, alcohol lamp or burner, empty soda can, ring stand, ring right here. It would look like this. And a wire mesh screen. So now I can hear this starting to go ahead and starting to boil. I'm seeing some steam coming out, which is a good sign for us with our experiment. We definitely want that. So what's happening now is that water vapor is starting to force out the air that's on the inside. It's starting to force out the air that's on the inside. The nitrogen and the oxygen, standard atmospheric air. Nitrogen about 78.084%. Oxygen around 20%, 20.946% I think, if my memory serves me right. And then a combination of rest for a very low percentage. Of course, carbon dioxide is included in there. Some ozone. And many others, but it's such a low concentration. So one of the things I'm listening to is it's starting to crackle a little bit. You definitely don't want to be putting your eyes up over this and looking in to see if it's boiling. You can see the steam coming up. So what is your hypothesis, or what is your prediction about what is going to happen when I put this into the pan of water? Keep in mind, it started out as I'm like one water droplet, and then in the liquid state, and then I turn into a gas, so there's 1,700 in me, moving really fast. And then what we're going to do, we're going to take this, and we're going to cool it down quickly. You can see a couple of things here. The can crushed. Why in the world would it be crushed? What happened? What in the world happened here? The can crushed. I didn't crush it with this. I couldn't crush this in this way, this fashion. And there's something else that is very interesting that has just happened as well. It has a vacuum seal on this pie tin here. So when I lift this up, you're going to see that there's been some water vacuumed up into this can. Also, I'm going to have a tough time picking this up. Or the seal just broke on it. Not only did it crush, but that is a lot more than 30 milliliters of water. That's a lot more. So now you can see the condition of this can. It's all crushed. What happened? Why did this happen? Why in the world would something like that happen? You have to tell me. Also, is vacuumed up some water as well. And if I would have taken it off sooner, this pan would have lifted up because there was a vacuum seal on it. It created a vacuum. The universe wants to be Goldilocks, balanced, just right, equilibrium. And when we created a vacuum inside of this Coca-Cola can, guess what happened? A bad situation for the universe. It didn't like it. It didn't like it at all. It said, wait a second, we have a situation that is unbalanced. It's not Goldilocks. So we had a high concentration of air on the outside, atmospheric air, basically here in Milwaukee, Wisconsin, kind of sort of at sea level, within a pretty good margin. We're not up on top of a mountain by any stretch of the imagination. Memory serves me right, I think it's 124 feet above sea level, but I'm not sure about those numbers. That would be something to look into. But at sea level, atmospheric air has a lot of pressure. Our bodies are just acclimated to it. So the atmosphere is pushing on us and our bodies are pushing back. But this Coca-Cola can couldn't push back because it had a vacuum on the inside of it. It couldn't push back because there was no atoms, no air, no water, or at very minimal right down here on the bottom there was some water. That's it. It didn't have anything to push back with. It didn't have a thing to push back with, so the atmospheric air pushed the can and it crushed. And now the universe is happy because it's all balanced. It's in equilibrium. It's Goldilocks. Please remember Goldilocks and the Three Bears, a very important concept. First porridge, I do believe, might have been too hot. The next one was too cold, and the last one was just right. That's what the universe wants to be. Balanced, equilibrium, Goldilocks. So we have a lot of science concepts in this one crushed Coca-Cola can. Isn't that cool? Science is so awesome. So many different concepts, such an innocent experiment, and yet so many profound concepts. Science is awesome, and so are you.